Alrighty, guys. So this is IM2 Statistics Day 2, and we're continuing to talk about probability. The Day 2 notes relative to the Day 1 notes are a little bit shorter, easier to digest. No pun intended there. We're talking about pie and ice cream and all this good stuff, so hopefully you're not doing this around lunchtime. But anyways, I think that this will be good to look at and kind of make sense of after all of the madness that you were introduced to yesterday with probability. So we are hitting this warm up first. We have 5 different kinds of pie: apple, blueberry, lemon, rhubarb, and peach. And there's also the 4 different types of ice cream: vanilla, strawberry, chocolate, and tangerine. Now you can go through and list out a sample space here if you really want to. But at this point, we introduced some formulas to you yesterday. Whenever you are looking at probability that includes and, okay? In this case, we are using multiplication. And the why behind that is in the Day 1 notes. So if you need to go back and look at that, you can. But from this point forward, we're just going to trust that the probability of A multiplied by the probability of B will work. And consider what is the probability of choosing peach pie. Well, there's 5 options there. Peach pie represents one of them, so that's 1/5. And then you multiply it by the vanilla ice cream representing one of the 4 ice cream flavors. And when you multiply those two probabilities together, you get a combined probability, compound probability of 1/20th. Okay, so the combination of peach pie and vanilla ice cream is one of the 20 potential combinations there. Now, what is the probability of a customer ordering peach pie or ordering vanilla ice cream? Now, those odds are going to increase because they don't have to be ordered together. They can be ordered separately, so that actually satisfies more within the sample space. So if we're going probability of A plus the probability of B minus this joint probability of A and B happening together, the 1/5 and the 1/4 makes sense. Now this 1/20th here, that comes from the probability of, 1/5 times 1/4. That's a little bit, actually it's exactly the same as what's above, right? 1/5 times 1/4, we already did that. We know it's 1/20th. So if you do 1/5 plus 1/4 minus 1/20th, that ultimately will give you 2/5. If you want to just throw this into Desmos Scientific, you can. It'll simplify it for you out to 2/5. I mean, if you do this without a calculator and you do this by hand, you would have to get common denominators. That's another way you could do it. When it comes down to it, though, that's going to be 2/5 or 40%. So our learning goal for today is to determine the probability of compound or multiple events, kind of like we were doing yesterday and kind of like we just did in that warm-up there. So we're going to continue with it. So continuing to talk about food here, we're at a local restaurant, and a dinner consists of one selection from each category. So you have an appetizer. You also get a salad, one of those 10 entrees there, and then also you have those choices for dessert. Now this right here is just a singular probability, right? This is not a compound probability. This is just simply looking at what is the probability that a customer orders chicken. Well, assuming that they have to choose one of the entrees and there are 10 entrees there, the probability that they choose chicken out of the 10 is 1 in 10. Easy enough. So probability of chicken is 1 out of 10. Now, number 2, this is where the compound part comes in. Okay, what is the probability that a patron orders meatloaf and also chocolate cake? Well, we have to consider them now together. So we're going to go probability of meatloaf and the probability of chocolate cake. So when we take the probability of meatloaf, that again is 1 out of the 10 entree options, where chocolate cake is 1 out of the 7 dessert options. And that's going to be 1 in 70 if we multiply 1/10 times 1/7. Now, I mean, if you listed out this sample space, it would take you a long, long time. There's like over 200, I think, maybe 300 possibilities. So this here is where you're going to have to kind of start working your way away from needing sample spaces and just trusting kind of what we've established thus far. Okay, so that's going to be 1 out of the 70, 1 in 70 chance there. For number 3, what is the probability that one patron selects steak or another patron selects pie? Okay, so in this case, we're looking at an or situation. Now, when we're going or, the formula that you guys came up with, and actually I don't have it here, so let me pause really quick and add it. All right, I just added it there in the red. So the formula for or, it was also up above in the warm-up, I realized, but you add the probabilities of A plus the probability of B, but then you subtract out the overlap because we don't want to count anything twice. So we're going to go the probability of steak, that being 1/10, okay, plus the probability of pie, which is 1 out of the 7 dessert options, and then subtract out the overlap where you've already counted pie and steak. And pie and steak together represents the probability of 1/10 times 1/7, which comes out to 1/70th. So that's just 1 out of the 70 options, but you still need to be wary of it and subtract it out from the 1/10 plus 1/7. So once again, if you throw all these guys here into Desmos, it would simplify it for you down to 3/7, or you would have to just get common denominators and do it the long way yourself. Now for number 4, what is the probability that a patron selects meatloaf? Simple, right? It's just one of the 10 entree options, so 1 in 10. Now, when it asks any entree except meatloaf, this is what's called the complement to the event. Okay, it's the complement to the event. So that's what this little C stands for here. That's why I put a little C here. So what is the probability of meatloaf's complement? Meaning basically that we choose anything but meatloaf. That's a 90%, 9 in 10 chance. Okay. Again, that's all that little C means there. Meatloaf's complement. It's anything that is not meatloaf. And that shows up again down here in number 6 as well when we're talking about a garden salad complement. Anyways, we'll get there in a second. What is the probability that a patron selects flounder, Caesar salad, and fruit? Okay, so this is these are 3. This is 3 probabilities now. So the probability of flounder, and the probability of Caesar, and the probability of salad. And if we take these 3 together, 1/10 multiplied by 1/4 multiplied by 1/7, that possibility there is 1 in 280. Okay, so if you come upon someone sitting at the restaurant there and they have the flounder with the Caesar salad and fruit option, there's a 1 in 280 chance of that happening. Okay. Now, finally, number 6, what is the probability that a patron selects pizza, cookies, and any salad except a garden salad? Okay, so we're going to go probability of pizza and cookies and garden salads complement. Okay, so we have the probability of pizza, 1 in 10 entrees, the probability of the cookies, 1 in 7 desserts. Okay, but now this is going to be 3/4, okay, because the garden salad represents 1 out of the 4 salad options, but we know that we're talking any salad except a garden salad. So that is 3 out of the 4 salad options. When you multiply those all together, it comes out to 3 in 280. So relative to yesterday, not too bad. We just got one quick example there. That's literally it. Be wary that there are always these extra resources down here. Khan is solid. He'll explain it in another way. I would consider looking through that video there if you need help. And really give that self-assessment and portfolio a try tonight, if I remember correctly. It's a really good one. Okay, so work on it. Come with questions for your teacher tomorrow. Alrighty.